Assalamu alaikum. So I have two signals here, and if you see carefully that these two signals are not identical, right? That means these two signals will have also different equation. So I will make two videos on this topic. In this video I will find the equation for this signal using the Fourier series concept. First I will use Fourier series, and then I will check my result is okay or not using a Python code, and I will teach you how to write this Python code at the end of this video. And at the next video I will do the same thing for this signal. Okay, so let's start. Okay, so to find the equation of these two signals, we have to remember the theory of the Fourier series. So at the first glance this series might seem difficult, but believe me, this is a very easy series. So let's first assume that this f is some kind of periodic signal. This f can be this signal or might be this signal. Okay, so we can express this f as infinite sum of cos and infinite sum of sine signals, right? You have 1 to infinity infinite cos and infinite sine signals with an offset a by 2. So theoretically we can have infinite signals, cos and sine signals, but practically we don't have infinite signals, right? So let's see what can we do practically. Let's go to our Python code and take only 5 sinusoidal signals, and if I run the code you will see that the signal is not so good, right? You see the square wave is not so good. Okay, let's increase the number. Let's say 50. We have 50 sinusoidal signals, and let's say what happens. Okay, the signal is better than the previous, and if I again increase the value, so I will have a square wave like this. And if I zoom here, you will see that the signal has a curve here, but a pure square wave shouldn't have a curve here. So I have to increase the number, let's say 50,000, and if I run the code with 50,000 sinusoidal signal, then this signal is also not accurate, but better than previous, right? And it's pretty good, a square wave. Okay, so practically we have to increase the number of sinusoidal signals, but theoretically you have infinite sinusoidal signals. Okay, so now let's come back to our theory. We have to find a naught, an and bn to find the signal f. And to find a naught I have a formula like this: an is equal to this and bn is equal to this. So don't be afraid, I will explain these three equations step by step. Okay, so let's find the first coefficient a naught. So here the capital T is the time period of this signal, and this symbol means we have to do a integration in this region. Okay, so we have to do a integration in this region, and this region is divided into two sub-region. For the first part, the signal's value is 1. That means from 0 to t by 2 the signal's value is 1, then t by 2 to t the signal's value is 0. So now we have to write this thing, that means 0 to t by 2 the signal's value is 1, then for the second region the signal's value is 0. So it's clearly understood that this second term will be equal to 0, and the integration of first term is very easy, it will be equal to 1. Okay, so now we have to find the value of the second coefficient, which is an, and now again this symbol means we have to do a integration in this region, and in this region is divided into two sub-region. From 0 to t by 2 the signal's value is 1, and t by 2 to t the signal's value is 0. So we can do the integration like this. For the first region the f is equal to 1, and for the second region is 0. So again the second term is equal to 0. So we have to do the integration in the first term. So if I integrate cos, we will have sine here. So let's write this thing here. Okay, so if I cancel 2 and 2, then t, then I will have an is equal to 1 by n pi. Okay, now this is t by 2, and if I put t by 2 here, I will have sine n 2 pi by t, then t by 2. Then I have a minus here. Then if I put 0 radian here, sine 0 radian means 0, right? Okay, then an is equal to 1 by n pi. 2 cancels out, t cancels out, then sine n pi. So I have a value an is equal to this, like this, and n can be 1 2 3 4 5 up to infinity. And if I take sine n pi, if you have a calculator, put sine pi, if you will see that this is equal to 0. If you take sine 2 pi, then it again will be 0. If you take sine 3 pi, then it will again become 0. That means sine n pi is 0 for all the value of this n. That means an is 0 for all the value of n. That means an is 0 forever. Okay, so what have we done? We have find the value of a naught, which is equal to 1. An is equal to 0 forever. So now we have to find the value of bn. So let's start. So let me write the equation here, and again I have two region from 0 to t by 2. The signal's value is 1, and t by 2 to t, the signal's value is 0, right? So I have to do the integration at the two region, and again like previous, the second term will be ultimately equal to 0. So we have to take the integration at the first term. So if I integrate a sine function, I will get a minus cos, right? So let me write this thing above here, and now 2 cancels out, then t cancels out, then we will have 1 by n pi, then cos n 2 pi by t. Let's write t by 2 here, so t by 2. Then we have to take a minus here, then cos 0 radian is equal to 1, right? So minus 1 by n pi cos, let's t cancels out, 2 cancels out, so cos n pi minus 1, and we can write this thing like 1 by n pi 1 minus cos n pi. Okay, so now I have to take n from 1 to infinity, right? But instead of taking 1 2 3 4 5, first I will take an odd number 2 4 6 8 10 up to infinity, and I will see what is the behavior of bn, and then I will take first I will take even number, and then I will take odd number up to infinity, and I will see that what is the value of bn. So if n is equal to even number, if you have a calculator, take cos n pi, and don't forget to convert your calculator into radian mode, because this n pi is not in degree, this is in radian. So cos n pi, if you calculate, you will see that cos n pi is equal to 1. So 1 minus 1 is equal to 0. So bn will be is equal to 0 for every even number. Okay, now if I take the odd number, if you have calculator, take the value of this cos n pi, and you will have minus 1. That means bn 1 by n pi, then 1 minus this cos n pi, put the value here, and you will have 2 divided by n pi. Okay, that means for the even number n is equal bn is equal to 0, and for the odd number bn is equal to 2 by n pi. Okay, so finally we have to plug the value of coefficients here. So the value of a naught is equal to 1, and we have find that the value of an is equal to 0, so this term will be equal to 0. and then we have find that for the even number of n, this Vn is equal to 0. That means this exists, the Vn will have a value when the n is an odd number, 1 3 5 7. So let me write here, n is equal to 1 3 5 7, Bn is equal to 2 by n pi. Okay, so let's write this here. Okay, so put the value of 1, so 2 by pi, then sine 2 pi by t. Okay, now for n is equal to 3, we will have 2 by 3 pi sine 3 into 2 pi by t. Okay, then again if I take 5, so 2 by 5 pi sine 5 into 2 pi by t, and this will goes on up to infinity. So this is the equation of the first square wave. So this is the equation of this kind of square wave, right? Okay, let's see how this Python code works. So first I have import numpy and matplotlib, and then I have set a0 is equal to 1. You can set it whatever you want, and the time period is equal to 10, and I want to see the data from -2t to +2t. So I have type here, but you can choose whatever you want. And then I take the offset a0 by 2 here, and then I want to take 50,000 sinusoidal signals, or I want to take number of summation is equal to 50,000, and then I have write the equation here, and finally I have plot this thing, and I get, let me run this code and let's see what happens. Okay, so this is my signal. So the signal's value is 1, then 0, then again 1, then again 0, and the time period of this signal is 10. Okay, so we have find the equation of this signal. Now we have to find the equation of this signal, but I have decided to make the long video short. I have decided to make a separate video on this signal. So I haven't make that video yet. So after uploading that video, to get the video, please subscribe to my channel and stay connected. Thank you.